Hello everyone. We are from Eleanor Roosevelt High School STEM Academy and our project is called Seeing Reality. There are millions of people around the world today that suffer from some sort of visual impairment. A visual impairment is essentially when there is a loss of vision that can't be corrected or restored to normal in any capacity. Our project was made in order to give people with visual impairments an affordable, feature-packed, and user-friendly package that can assist them in day-to-day life.
There are devices that aim to help people with visual impairments, but there are a few qualities that the vast majority possess that make them unusable or unobtainable in daily life. The main issue that we find with them is price, as most are priced between $5,000 and $10,000, which is extremely expensive and too much for the average person to spend on an assistive device. Another dilemma with these devices is the size. Many are just too big to carry around all day, weighing significant amounts and not being portable enough to take with you every single day.
For the past 2 years, we have focused on building and refining our apps, giving them more functionality and accessibility than ever before. Last year, we improved our text-to-speech app by moving from the OpenCV library that we had used in the first year of our project, which was much slower and less accurate than Tesseract OCR, which is the library we used last year. We have since then updated the library to Apple's Core ML, which utilizes machine learning and AI in order to give more accurate results. This also allowed us to scan even more text at a time.
This year, we wanted to create a standalone device that is completely detached from a phone. This device utilized the Raspberry Pi, a display, camera, and battery to complete a completely separate device that operates discreetly. Because Core ML is a standard only supported on Apple hardware, we weren't able to port it to the Raspberry Pi device as it runs Linux instead of iOS, so we ported over Tesseract OCR because it was the most compatible and most stable. We do expect results to be worse overall, but we'll get into that later.
We focused on improving both aspects of the project, first improving text-to-speech on both the devices, and then adding object detection to the phone, making it even more versatile. Our object detection essentially scans the item and the item name pops up on the screen along with the confidence percentage out of 100. The higher the number, the more confident the app is that it correctly identified the item. This, combined with the other 3 parts of our app, makes for a lot of flexibility depending on what the user wants to do.
Because we mainly focused our efforts on making the text-to-speech more reliable and faster, we did most of our testing on its accuracy. We tested 7 different fonts, each with a unique look and different characteristics. We tested Times New Roman as our baseline font, Papyrus as a thinner font, Kunstler Script for a cursive style font, Comic Sans, Chalk Duster to see if it could detect text through messier writing, Segoe Print, and Britannic Bold. For each of these fonts, we tested different sizes as well. All fonts were tested at 14 sizes ranging from 2 through 28, going up each time by increments of 2. We tested all fonts and sizes first at 1/2 foot and then 1 foot on both of our testing apps using our Raspberry Pi, using Tesseract OCR, and our new machine learning AI scanner.
We hypothesized that our phone app using machine learning and AI will be able to read from 1 foot distance all fonts aside from cursive from a size of 12 and up, and from a 1/2 foot distance a size of 8 and up. We believe that our Raspberry Pi using Tesseract OCR would be able to do the same, but from a size 16 and up for 1 foot and 14 and up for 1/2 foot. We believe that Tesseract would have a difficult time reading anything smaller than 16 and 14 respectively, as its processing just isn't as good as our AI-enhanced iPhone app.
As you can see from our tables and data, when we look at the results for Tesseract OCR running on the Raspberry Pi at 1 foot distance from the paper, we can clearly tell that the app doesn't recognize anything that isn't one of the largest font sizes on any of the styles of font, and on some, specifically the cursive font, doesn't recognize any characters at all. For the rest, it is able to recognize most of the characters at size 28, with Times New Roman and Britannic having a few missing each. Anything smaller than 24 isn't recognized in any capacity and doesn't even get detected.
At 1/2 foot on the Raspberry Pi, the results are a lot better. It still isn't able to recognize the cursive font, but that's expected. For Papyrus and Times New Roman, it is able to recognize all the way from 16 through 28 with 100% accuracy. Comic Sans presents good results, performing better by being able to recognize 34 out of 35 characters at size 14. Segoe and Chalk Duster also do well, where the app is able to recognize sizes 12 through 28 with very high accuracy apiece. Looking at the data for the machine learning text-to-speech app on the iPhone, we can see that the results are exceptional. It is able to recognize all fonts except for cursive from 8 through 28 with 100% accuracy from 1 foot and 1/2 foot.
The cursive results were very impressive on the phone app, given that the Raspberry Pi using Tesseract OCR wasn't able to recognize any text at all, even at 1/2 foot away. The fact that this was able to recognize any at all from 1 foot is incredible. It was able to recognize the text from sizes 10 to 28 and got over 30 characters correct on 3 font sizes. The numbers only got better when we go to 1/2 foot, with even higher accuracies across the board. As expected, at both lengths, it did exceptional on all the other fonts, only failing to recognize some of the smallest. Another item we added this year is object detection. We tested a few different household items and recorded if it recognized it correctly, and the confidence level given in the app. We tested an orange, remote, Apple, computer mouse, and a laptop, all of which were recognized accurately, with above 80% accuracy for all. Because this app doesn't use any proprietary software from Apple or any other company, we were able to port this to the phone and then the Raspberry Pi model, which is our standalone device. In the end, our hypothesis was partially correct in the sense that our Raspberry Pi app wasn't as accurate or as reliable as our phone app. Although we didn't anticipate the phone app being able to read cursive at all, the object detection portion was also successful and provided us with good data to improve the app as a whole. In the future, we would like to do more testing with more libraries and machine learning tactics to improve functionality and the user experience as a whole. Where did you get the idea for your project? At school, we have a close friend who has suffered from a severe visual impairment his entire life. Every day, we would see him using big and bulky devices to assist him, and we knew that there had to be a better way. When we looked online and at stores, we didn't find anything that was priced reasonably, was portable, and had good functionality, so we decided to create our own. What interests you most about the subjects you chose? The most interesting thing about this project to us is the trial and error of our design. We've created many designs and went through many iterations for every aspect of the project, and finally getting it exactly the way we wanted to is incredibly satisfying. Why is your project important to today's society? Our project aims to help the millions of people out there today that suffer from visual impairments, similar to our friend. Our goal was to provide great functionality, a user-friendly and easy experience, and give the user a device that was portable. And all these features just don't exist in a device today. In general, what were your results and conclusions? Our results and conclusions essentially tell us that the improvements to the text-to-speech app have allowed the user to scan significantly more text at even greater accuracies than before, making it even easier and simple to use. Adding object detection to the app also helps the user to recognize different objects easily, and the fact that it was able to recognize all objects we tested with very high accuracy makes it an extremely reliable add-on to both devices. What is special about our project? Our project targets a large group of people who just don't have any good options on the market today. The qualities that our friend, and we for that matter, would expect on a device like this just didn't exist and don't exist. And this was something that we wanted to provide for the people that need it the most. Thank you for listening to our presentation.